Today's Daily Dose of Math is happening on March 23rd, 2020. I normally don't say the date when I make a math video, but I'm doing it this time because right now we're in the middle of the spread of the coronavirus. And today's Daily Dose of Math is about the exponential equation that you can create when you have data that increases exponentially. Virus spread is increasing exponentially. That's how it works. In my Secondary 4 Algebraic Modeling course, students are required to be able to create an exponential equation of the form y equals ab to the x from a table of values, and then use that equation to answer questions. This is an algebraic model, which means it's an estimate in an equation of the situation. In order for the equation to be perfect, we would have to have perfect data, and we don't. What I started with is information from a newspaper article that shows that 2 days ago there were 139 confirmed cases in Quebec, and yesterday there were 181. I know that the first case was identified in Quebec on February 28th, and I've made that day 0 in my table of values, so one case on February 28th. That means the day before yesterday was day 21, and yesterday was day 22. I'm able to take these 2 points in the table of values and plug them into the form so that I get these two equations. 181 equals ab to the 22, and 139 equals ab to the 21. Now I'm going to divide these equations so that I can get an estimate, an approximation of my b. The first thing I'm doing is I'm isolating the b in both equations, and I get these. And I can divide the two equations. It's convenient to use 2 days in a row from the table because b to the 22 divided by b to the 21 is b, and that part goes very fast. But I also have to divide this side, so I have 181 over a divided by 139 over a, which is 181 over a times a over 139. The a's cancel. All I'm doing is 181 divided by 139, and my b is therefore equal approximately to 1.3. Now this number is rounded. And when you do things like rounding in an exponential equation, it can have quite a big effect on your finished model. Also, when you use data that's not perfect, it can also have a big effect. So I have to remember that this is a model. It's an approximation. And now that I know my b, I'm able to use it to help me find my a. I can write my equation now as y equals a times 1.3 to the x, and then plugging in one of the points from the table of values, 181 equals a times 1.3 to the 22. A therefore is equal to 181 divided by 1.3 to the 22. Remember, BEDMAS, we have to apply the exponent before we do the division. A ends up being approximately equal to 0.56. And I have an equation, y equals 0.56 times 1.3 to the x. Now I can make a prediction using this equation. March 31st will be day 32, and I'm going to plug that into the equation. And simplify, and I get an approximate answer of 2,480. That means that if my equation were correct, on March 31st, there will be 2,480 confirmed cases in Quebec. I've done the same thing for the world. I didn't have room to show all of these calculations on this small chalkboard, but I was able to get information from a website that gives a running total every day of confirmed cases. And 2 days ago it was 307,652. Yesterday it was 337,444. Both of those readings were taken at 10 p.m. The problem with this data is when I fill in my table of values, I don't know what day 0 is. No one knows what day 0 is for the world. It was sometime in December. So what I did was I just estimated that day 0 was on January 1st. And I built my table of values that way. I filled in the form with the 2 points in the same way. I divided the equations and I got an approximate b of 1.1. And then I did the same step that I did over here to get an approximate a of 136. So I have this equation, y equals 136 times 1.1 to the x. When I plug in day 90, which is March 31st, I end up with an estimated number of confirmed cases for the world of 722,571. I will revisit these equations and these approximate values that were calculated at the end of March once the data's in. And we'll see how good my algebraic model is. But one thing that I can predict is that I'm not going to be surprised if the numbers we get, both for Quebec and for the world, are smaller, lower than these numbers. Because of what? Because of all of the things that people are doing to try to curb the spread of the virus. The social distancing, the quarantines, the cancellation of major sporting events, the closing of schools. This is going to have an effect. It's not going to stop the virus from spreading. It's going to make it spread more slowly. So that is today's Daily Dose of Math. Please like and subscribe.